So this is a video about finding the center of rotation when you're rotating a shape from one position to another position. You've hopefully already watched my previous video telling you how to rotate a shape. So that involves starting with one shape and then getting a compass, having that compass set with the point at a particular center of rotation, and then turning all of the points one by one through a number of degrees to get to another point or another shape, point by point. And then hopefully you've also watched my previous video about finding the perpendicular bisector. So when you've got a straight line, finding the line that cuts it exactly in half at 90 degrees. So both of those are kind of required previous viewing for this. Okay, let's just get rid of this, give myself a bit more space. So there's two shapes, and one of them's been rotated to get to the other. So let's say we started here and it was rotated clockwise to get to there. So it's been rotated around a particular point, a particular center of rotation. And the object of this video is to find out exactly where that center of rotation is. So let's say it was here, then it's rotating. Oh, that's not quite right. So the center of rotation must be somewhere else. Let's try here. If we put a compass point in there, that doesn't go to the right place either. So, you could do it by trial and error, but there is a more precise geometrical way to construct something that will figure that out for you. So first of all, I'm going to look at one of the points on one of the shapes. So let's say that shape there, and I'm going to label it, let's say A, and then its rotated equivalent over here, let's call that A dash. So they're basically the same point on the two different shapes. One's the rotation of the other. Now what I'm going to do is draw a straight line between those 2 points, A and A dash. So I'm drawing a line between a point and its equivalent point in the rotated shape. And then I'm going to do the perpendicular bisector of that line that I've just drawn. So line there, or an arc there, and then an arc there. So 2 arcs, and then when we find the perpendicular bisector, we just join up where those 2 arcs meet. So I've done that in, it's slightly red or pink, you might not be able to see that on the video, but it's a red line, and that's the perpendicular bisector of the line between A and A dash. I'm now going to rub a whole load of stuff out because this is very quickly going to get rather cluttered if we're not careful. So I'm rubbing everything out except my original shapes and the perpendicular bisector between A and A dash. So we're left with A and A dash and this red line between them. So if you imagine yourself walking along that red line, you're always the same distance from A as you are from A dash. That's what a perpendicular bisector does. Now when we rotated A to A dash with a compass, we must have had our compass point in somewhere on the paper and then started at A and then kept the compass until we got round to A dash. So A and A dash are always the same distance from the center of rotation because our compass is always set at the same length from the center of rotation. So we know that the center of rotation is the same distance from A and A dash, and we know that this red line is all of the points that are the same distance from A and A dash. So in other words, the center of rotation is somewhere along that red line, but we don't know exactly where. But I'm going to think about another point there. So I'm going to call this point B, and then its rotated equivalent B dash. Then I'm going to do exactly the same thing again. So I'm going to draw a line between them. And then I'm going to find the perpendicular bisector of that line, with my compass. So an arc from one end, an arc from the other end, keeping my compass the same length all the time, and then I'll make it another red line between them. And just rub out some of the other stuff because it's starting to get a bit cluttered again. But I'm left with this red line that is the perpendicular bisector between B and B dash. So this red line is always the same distance from B as it is from B dash if we walk along there. So because it's the same distance from B and B dash all the time, and because when we rotated the shape we were the same distance from the center of rotation to B as we were to B dash, that means the center of rotation must be somewhere on this line. So the 2 points A are telling us that the center of rotation is somewhere on this line. The 2 points B and B dash are telling us that the center of rotation is somewhere on this line, and they both meet up here. So this point here must be where the center of rotation was. And we can just verify that if I get my tracing paper and put it over the original shape, and then I'll just stick my pin in where I think the center of rotation is, and then I'll try to rotate it, and there it lands in exactly the same place.